Hello, today we're going to look at the roots, radicals, and complex numbers. Okay, so we need to be able to simplify radicals, especially square roots, when solving quadratic equations. Okay, so let's start with the warm-up. Okay, and so with this warm-up, you're asked to simplify each radical. Okay, now if it doesn't have a number for the index, that's a 2. So we're dealing with the square root of 36. So we're looking for a number squared that gives us 36. And so we can see that positive 6 or negative 6 squared gives us 36, but we want to look at the principal square root, okay, or the principal root. So when we think about the square root of 36, okay, we get 6. So really we get negative 6 and 6, but this is the principal square root. But these are the roots, the two roots, but we're looking at the principal square root. So if you ask for the roots of the square root of 36, you would actually put negative 6 and 6. All right, but when you're looking for the principal square root, the square root of 36 is 6. The square root of 100 would be 10, because 10 squared gives you 100. Negative 10 squared also gives you 100. So that's dealing with the square root. So when we get into the cube root, we're looking for a number multiplied by itself 3 times. That's going to give us this number. And so the question you ask yourself, is 8 a perfect cube? Yes, 8 is a perfect cube. So what cube gives you 8? 2. So the cube root of 8 is equal to 2. Now when you get into the variables are probably easier to deal with than the numbers, okay? And so pretty much if I'm dealing with the square root, this exponent here, we're just dividing, okay? So in other words, it's like we have the square root, I have 2 x's. So I'm dealing with the square root, I'm looking for a pair, just like we were doing up here. And so I do have a pair, so that means this is a perfect square. So the square root of that pair is just x, okay? And so basically you're doing 2 into 2, all right? Power over the root. The root is 2. And so here, again, this is a 2. The square root of x to the 20th, what do you think the square root of x to the 20th is? That means I have 20 x's all the way across, which means I would have 10 pairs, okay? And so basically, another way of looking at this is 20 divided by 2. So the square root of x to the 20th is x to the 10th, okay? So it's perfect. And so right now we dealt with perfect squares or perfect cubes. Now looking at problem 6, we have the square root of 27, okay? Is 27 a perfect square? No, it's not. However, we can simplify it using radicals, okay? We have the square root of 27. We can break that down, okay? And so we can break 27 has a perfect factor. That is a perfect square. So we can do 9 and 3, okay? And so the square root of 9 is 3. And we're left with 3. Okay, and so that's simplifying. All right, so that's a warm-up. All right, so we're going to get into looking at the simplifying radicals, and we'll also get into the complex numbers, okay? And so dealing with the a plus bi form, okay? Rise your imaginary number. So when dealing with the complex numbers, just keep in mind that I squared is equal to -1, and the square root of -1 is equal to I. So given that, so if you have the square root of a negative number, you can't have a real root, okay? So for example, if you have the square root of -36, okay, automatically this is like the square root of -1 times the square root of 36. And the square root of -1 is I. So I automatically comes out. and then the square root of 36 is 6, so that would make it 6i. It's a complex imaginary number. And so if we have the square root of -9, okay? So that would be 3i. And suppose we have the square root of -3. Well, 3 is not a perfect square, and 3 is simplified, so the only thing that comes out is I. So we still would have the square root of 3, and then I would be on the outside. Okay, so that's dealing with getting into simplifying a radical when you have a negative under it, okay? A square root. So simplifying the square root when you have a negative inside. All right, so let's look at, let me save this. So let's look at, okay, some problems. So if we look at this, again, we are find each root that is a real number, okay? And so, and looking at the viewing example will show you how to put your answers in, okay? And so they're looking at just looking at that, okay, the only, right. So they're just looking at the principal root. So when we do this, okay, so that would be, you have a negative on the outside. The square root of 16 is just 4, so that would be a -4. So that's basically what they're looking for. I think you know how to do that one. This is an approximation. Again, you can look at the view and example to see how to approximate. Again, this is not a perfect square. We have a 124.5. And so you want to look at, to approximate, basically, you look at a number less than this, and that's a perfect square, and a number that's greater than that, that's a perfect square. So if we look at this, okay, what number would come to mind that's perfect? Okay, let me let's put this on the board. Okay, so if we look at the number 124.5, we know that's not perfect, okay? And so the number, we got, well, 121, right? Because maybe you might have to go down your list. We have 11 times 11 is the 121. All right, because that's 11 times 11. And then the next one, okay, so if we do 12 times 12, okay, that will be the next in line, so that's 144. So, all right, so that means it says choose the closest approximation, okay? And so the closest approximation for this one, this is 144, this is 121, so it's closer to 11. Okay, good. That's all you're doing. Perfect squares. All right, so when it wants you to find all of the square roots of 9, okay, this is when they give you, all right, so here, one square root of 36 would be 6 times 6, another square root of 36 would be -6 times -6. So this is this is what I was talking about when you're finding all the roots of that number. And so, and you separate it by comma. So what would be your roots of 9? So you would put 3 and then comma -3. Good. And then check. Very good. All right, same thing with that. All right, now, okay, then square root. All right, so now we get into the imaginary. So if you put this in your calculator, you put in the square root of a -4, you get an error because it's not real. So remember, we just dealt with this. So therefore, the square root of -4, that would be imaginary. So the I is going to come outside. So that's I times the square root of 4, and 4 is a perfect square, so that's 2i. All right, and so another one, which is not, okay. And so here, found the square of the radical expression. So if we square it, now, this is what I want you to know, okay? So if you square, okay, a square root, you're just going to be left with what's inside, all right, because these were canceled. So if you have the square root of 3x to the 9th plus 3, and I square it, okay? So this gets you into the habit of when you get ready to solve nonlinear equations, okay? You want to get rid of radical. You square both sides. That will eliminate your square root if I'm dealing with a square root. And if I was dealing with a cube root, I would cube it to get rid of my cube root. And so when I square square root, I'm just left with 3x to the 9th plus 3. Okay, that's it. All right, so here, this is the rational exponent. It's written as a fraction, so let's look at that. So if I have some number and then m to the n, I say power, I should have said p over r, over root, okay, because the power over root, that's how you rewrite it. So I have 7 to the 1/2. This bottom is my root, so I'm dealing with the square root. So that would be the square root of 7 to the first power. All right, so let's write the following exponential as a radical. So that would be the square root of 7. Same thing if I had like 7 to the 2/3. And so that would be power over root. So I would be dealing with the cube root of 7 squared, or I can write it as the cube root and write it like this, squared. But this is, I can't simplify this anymore because, you know, this is a 3 and this is a 2. So as long as the power is less than the root, then it's simplified. Now, if this was a, let's suppose it was 7 to the, 5/3 or something like that. If I did that, then that's the cube root of 7 to the 5th, right? Which means I would have 5 sevens, which is, I'm looking, cube root would be 3 to a set. So if I'm dealing with the cube root, that's 7 times 7 times 7 times 7 times 7. So cube root means 3 of a kind. So I have one set, okay, and these two would have to stay up under. So the cube root of this set here would be perfect. So 7 comes outside, and that would leave us with a 7 squared on the inside, or 49, okay, since it's so small. So that would be the cube root of 49, okay? So I just want you to play, that's just playing with it. And same thing here. Can be 40. Since it's a small number, you can just go ahead and put 49. All right, but that's getting you in the habit of converting your rational exponents to radical form, okay? And then you can convert your radicals to exponential radical exponents. Okay. All right, here you want to be careful with this one. The negative's not raised to the 1/2, just the 16 is raised to the 1/2. So that goes back to an initial problem. So the negative 16 to the 1/2. So 16 to the 1/2, this is the root, is 2. So that would be the square root of 16, negatives on the outside. So this is a perfect, so that's -4. Okay? All right, good. Okay, here we go. So we have something different, and you can see how the top is bigger. So we're dealing with the square root, right? Because that's at the bottom. That's dealing with 36 to the 5/2. That's dealing with the square root. All right, so we know we're dealing with the square root of 36, and that's to the 5th. So we can go ahead and put that on the outside because we know we can take the square root of 36, which is 6. and that's 6 to the 5th. And so it says type an integer or simplified fraction. All right, so here, let's just see what 6 to the 5th gives us. Okay, so not too big. So it gives us 7776. Okay, so let's put in, oh, I can't do it right there. 7776, and let's put it in here. All right, and let's see if this is correct. Very good. All right, so you know how to simplify a square root, a cube root. When you have a negative under a square root, and how to convert a rational exponent to radical form, okay, and simplify. And so here, again, we're dealing with the imaginary. So we have the negative of the square root of -1. So I told you that the square root of -1 is I, okay? And then I squared is equal to -1. So you want to keep those two in mind when you're dealing with these complex numbers. And so that would be a -I, because you just bring down the negative. Good. All right, so we're dealing with that. You know how to deal with that. Now here, we dealt with this in the warm-up. When you have the square root of -5, well, 5 is simplified. You can't do anything with it, but I will come outside. So we're still going to have the square root of 5, and then you'll have I on the outside. So it's in the form of A plus BI. So let's see how to put that in. So you would put in your square root, which is at the bottom here, square root, and then put in 5, and then arrow, and then I. And I is not under the radical, so it's just to the side. If you put it under the radical, it will count you wrong. Okay. All right, so now we're going to get into simplifying, finding the perfect squares in a number. Okay, and so we got a combination of dealing with imaginary as well as being able to simplify a radical. So this is what you'll need. You may need if you're using the quadratic formula to solve quadratic equations. Okay, so let's put this on the board. So we have the square root of -80. So right away, I know that I is coming outside. Okay, and now 80. So you can either do the prime factorizations, or you can find a try to find a factor of 80 that is a perfect square. And so if you can't do that, it's okay. You can break it down. Let's break it down. Okay. So if we break it down to the prime factorization, okay, that's like dealing with a tree. So we can do 8 times 10, right? 8 is not prime, so we got to break that down. We can do 2 times 4. 2 is prime, so let's circle that, but 4 is not. So we break that down to 2 times 2, right? So we got another 2, another 2. Is 10 prime? No, so let's break the 10 down to 2 and 5. 2 is prime, 5 is prime. So up under this radical will be the circle numbers. So we got 1, 2, 3, 4 2s, 1, 2, 3, 4, and a 5. Okay? And so I'm dealing with the square root. So, okay, square root, find pairs. Find 2 of a kind, okay? That will create a perfect square. Cube root, you find 3 of a kind. That creates a perfect cube. And the fourth root, find 4 of a kind. You know, that creates a perfect, you know, fourth root, etc. Okay, so I'm doing 2 of a kind. So I have a pair here, and I have a pair. So I have 2 pairs. So you can take the square root of each pair. So look, so that 2 times 2 is 4. The square root of 4 is 2. So your answer is looking right at you. So what's coming outside? 2 2s. We still have I, and then the square root of 5. It has no partner, stays inside. So I have 4, and you can just go ahead and put the I on the right side since it's in this form right here. So you can do 4 square root of 5 times I. And then it may allow you to put 4i times the square root of 5. I'm going to put that just to see if it will accept that answer. So if I put in 4i, and then the square root of 5. Just want to see if it's going to take it. 5. Just want to see. It did. Okay, so it accepted it. This one here can be tricky. So let's look at this one. When you are multiplying radicals with negatives under it. So if we have the square root of negative 2 times the square root of negative 3. This does not equal to the square root of positive 6. No. So you have to be careful. Deal with these negatives under here first. So the square root of negative 2 means I comes outside. Here means I comes outside here. Okay? Deal with that. And then I times I is I squared. Now you can put your, I'm dealing with square roots, I can put the numbers up under the same root. And so what is I squared? Good. I squared is negative 1. And then up here, this is 6. This is simplified. So that gives me a negative square root of 6. Okay, so you want to be careful with that. Good. Here you're just adding and subtracting complex numbers, just as you were dealing with algebraic expressions, except we have I involved here, okay? So it works just like an X when you're adding and subtracting, combine like terms. All right, same thing here. All right, so but when we're multiplying, just keep in mind that 4i times 3i, okay? 4 times 3 is 12. I times I is I squared, okay? So anytime you have anything higher than I to the first power, you have to simplify. I squared is equal to negative 1. You have to replace that. And so that gives you negative 12. So you have to remember that. Anytime you have an I squared, you have to simplify it, replace it with negative 1. Now, suppose you had I to the 4th. I to the 4th. So we can really rewrite this, okay? So bring back in your laws of your exponents. We can write this in terms of I squared, right? So that would be I squared. I can raise that to the 2nd, right? And so that would be negative 1 squared, which is 1. Or I could have said I squared times I squared, which is still, you know, negative 1 times negative 1. So that's for an even number. So what if you have a odd power? Can I get that in terms of I squared? Well, I can separate it. So I can do I and then times I to the 24th, right? Because I is just I. And so I can say I times I to the 24th, which is I to the 25th, right? Now we can do the same thing with this one as we did up here. Write it in terms of I squared to a power. So that's I times I squared raised to what? Good, to the 12th, because when you have a power, you multiply. So that would give me 24. So this is negative 1 to the 12th. That's an even number of negative signs, which means it'll be positive. So that's I times 1, so that's I. Okay? So I just wanted to just make you aware of it can be higher than I squared. Suppose it is, what do you do? So that's what you do. Okay, so that gives you some idea of how to work with your roots and your radicals and your complex numbers. Okay? If you do have questions, please let me know. And I will be happy to help.